Hello and welcome to the session Major Updates on the ABAP RESTful Programming Model. My name is Marcel Hermanns and I will give you some insights on RAP. So the agenda for today is basically the big picture of RAP, a short recap why we built RAP, what's in and how the complete picture fits together. Then we will have some deep dive into the draft handling which we included into RAP. Of course, we also include a live demo here showing all the new features and a lab preview of what will come next. And in the summary, we will give some overview about the delivered features and an outlook for the next releases. So first of all, what is the big picture? The mission of RAP is that we provide a programming model as a long-term solution for the ABAP development. So of course, such a big programming model which we are creating is nothing that you want to create every 3 years. So for us, it's a strategical investment from kernel, ABAP language side, from ADT side, and also the frameworks which are running in the background. So of course, we also want to support different development scenarios. So first of all, it should be very easy to create applications from scratch. But one thing which we learned in the last years is that it's very, very important to support also use cases where we have existing application code. So one of the goals which we want to move forward with RAP is that it is very easy to integrate the different scenarios where you have existing application coding. So besides this integration of existing application coding, one of the key features and things we want to move forward with RAP is the development experience. So of course, high development efficiency is very important. We want to offer a standardized development flow, which will guide you step by step through the development scenario, supported by best practices and development guides. And our goal is that always the application developer can focus on the business logic rather than technical aspects. So it's not good to implement an OData protocol on gateway level if you can invest the time into your business, into a real business logic. So therefore, we want to take over the technical aspects so that you can do the focus on the business logic. Of course, native testability, documentability, and supportability support is really important for us. So we have a testability, which is highly integrated into the tooling in ADT, but also in the kernel. So we have now a native support of business objects in RAP, as we can see later. And also the testability of these business objects is natively integrated into the language. Code push down via CDS and AMDPs is very important for us, but also that the business objects which we are going to create also run in a stateless and in a stateful environment. So we introduce RAP for the stateless support in Fiori, for web APIs and things like that, but it's also very important for us that the BOs created with RAP also run in older scenarios, in stateful scenarios. So of course, product qualities like user experience, the cloud qualities, and out-of-the-box extensibility and verticalization is very important for us. So let's have a look on the big picture. So this is really important because this shows the different layers of RAP. So the lowest layer are the business objects and the CDS artifacts. A business object always consists of 3 parts. First of all, the data modeling. This is done via CDS. We have one root CDS view, and we have a composition tree below that. Behavior definition includes all the behavior a business object has, actions, functions, the concurrency handling, and also maybe the draft support if it is required. And in ABAP, we're gonna implement all this functionality, of course. And then based on the business object, we need role-specific views of this business object or the CDS artifacts. So these are projections. Projections project only the data and also the functionality, which is really required for the scenario. And the complete scope, which is required for one particular service, so web API or Fiori UI, is then the scope is then defined in a service definition. So the service definition is a bracket around the scope which should be exposed. And the service definition itself is still a CDS artifact, so completely protocol agnostic. The service binding is now the place where we decide for which OData version, or maybe also other protocols in future, and also for which use case we are going to support to expose the service. We can decide if we go for Fiori UI or for Web API. Because we already know that on the tooling side, whether we go for Fiori UI or Web API, we can also enhance the tool support. So for example, for Fiori UI, we could show Fiori Elements preview, and for Web API, we could show a Swagger UI preview. So, but what about the business object runtime now? This is really important. So a business object model contains for us 3 parts. First of all, the interaction phase. secondly, the transactional buffer, and finally, the save sequence. So the interaction phase is the period of time when the end user presses the edit button until he or she presses the save button. And all the changes while the end user is in interaction with this backend, with a business object or even multiple business objects, all these changes are written to the transactional buffers and are stored there. And when someone presses the save button, then all these changes are written to the database. And of course, multiple business objects can be involved in one scenario. Therefore, it's really important for us, and that's also one of the key changes in RAP, that we can orchestrate the save sequence of different business objects in parallel. So first of all business objects have to finalize the latest changes. Because maybe changes are too expensive to do that in the interaction phase or are not reasonable, we can do the latest changes in the finalize step. In the check before save, every business object can complain for the last time whether or not the current status is consistent. If it's not consistent, then the save sequence is interrupted and we are again in the interaction phase and the end user can correct the issue. But if every business object is fine with the current state, if it's consistent, then we are beyond the point of no return. That means coming from here, no business-related issue can occur anymore because we draw the late numbers. For legal reasons, they should be number-free, gap-free. So therefore, we draw them after the point of no return. And in the save, finally, the update task function module is called and the data is written to the database with a commit. So, but now it's important how the business object runtime looks like. So, for example, a managed BO can support greenfield scenario, and an unmanaged BO is exactly fulfilling the use case of integrating existing application coding. So, for brownfield scenario, where the application coding already exists, an application developer can implement create, read, update, delete, log, and the save sequence by delegating to the existing application code. So, for example, in SAP scenarios, the sales order implemented via the goal framework or the purchase order implemented by a function module would be such a scenario where the coding is decoupled from older technologies and can be reused here in RAP. And if we integrate it once into RAP, we can benefit from all the integrations RAP builds on top, covering the technical aspects again. And now in managed scenario, it's like in the BOPF scenario. So that means the application developer basically gets CRUD functionality for free, but only the business logic via determinations, validations, and things like that can then be used afterwards in order to implement the business logic. So, but also in case the business logic is available in some scenarios, so for example, where we have an update task function module or where we have the database, the log implementation already available. In these cases, we can use unmanaged exits in a managed business object to include this functionality here. So, but how does the development flow look like? So first of all, we start with the database table. On top, we create the CDS artifact. You remember the business object contains three parts. First of all, the data model. Secondly, the behavior definition. And last but not least, the real implementation. So this is what we're going to do here. The CDS model, the data model is extended via behavior. And then the behavior is implemented in the ABAP code. So depending on the use case, this is now the CRUD functionality for unmanaged BO or the implementation of determinations and validations for managed BO. Of course, we can reuse log objects if available, or we can make use in a managed scenario of the generic log object, which comes for free. Of course, also authority checks are important for the transactional behavior, and we want to reuse this authority object also via DCL for the CDS queries. And unit testing can, of course, be done for each individual determination, validation, or the CRUD implementation, which is done in local classes in these handler classes. And this behavior pool containing abstract classes can then be instantiated in test coding to also have unit tests for determinations and validations, for example. Scenario tests calling the complete business objects end-to-end are then implemented via EML, also in AUnit classes. These are, of course, no unit tests, but scenario integration tests. But we also make AUnit we use AUnit as a framework for tests in general. And then, as I said, based on the business objects, we create the projection. On top of the projection, service definition and service binding. This can also be seen here on the slide. So we create a projection for the model, data model, and also for the behavior. And on top, we create the service definition, defining the scope of the particular service. And then in the service binding, we bind this service towards a protocol and a use case. And in case of Fiori Elements, we do have a preview, Fiori Elements preview, showing the application then live in the system. And of course, a role definition is really important to get the service running. And what we introduced newly here is that via gateway, local client proxy, we can also test the OData services without calling HTTP. So by calling the service locally, we can make use of the test double frameworks for CDS, SQL, and also newly integrated or newly provided by us also for BO frameworks. So, but how does the draft handling look like? So first of all, draft is really important for us. Draft is a key enabler for modern UX and also for the cloud enablement. Why? Because in the cloud, we have high availability requirements, continuous delivery and low TCO. And RESTful provides now the status communication approach that we can really avoid problematic server stickiness. Because only if the server is not running in the background, we can make an upgrade, for example. And RESTful says that between two round trips, no stateful communication should be there. The session should not run further. And the draft is now our solution to fill the gap between the stateless communication and the stateful application. Of course, from an end user perspective, it's a long-running transaction, more or less, an application with changes which are stored. And now draft fills the gap by persisting these changes in the database, and therefore we can offer a stateless communication. On the other hand, we need the draft also to cover modern user experiences, multi-device support, data loss prevention, and to prevent also connection timeouts. We don't want to have a connection timeout if we go into the coffee corner. And now the reason why we can achieve that is that the draft persists the state device independently in a non-process relevant way. That means that the changes are stored in a shadow table and they are not relevant for analytical reports, for example, but they are stored in shadow database tables device independently, and we can refer to that from any device, from any browser tab where we want to do that, as we can see later in a demo. And now RESTful helps us again also with the draft, because now RESTful makes the draft addressable as a resource. So the draft is a separated resource with a different key, which can be accessed, and also verbs like create, update, delete are allowed on the draft instances. And therefore, our guiding principle is what we always keep in mind in our design decisions, and which is also really important to understand that if you implement the draft is a persisted transactional buffer as an addressable resource. And therefore, our model of a business object with the interaction phase, with the persisted, with the transaction buffer, and with the save sequence also fits to the draft, because the draft is the transaction buffer, which is simply persisted as an implementation detail. So, but what's now the difference between the draft handling and non-enabled draft application? If I don't have a draft application, between edit and save, there is no backend request. And therefore, we can also not execute backend logic. So therefore, we get not much feedback from our application. The end user only gets the feedback when the save button is triggered. But now with draft, it's a little bit different, because between edit and save, there are multiple requests to the backend, like also for classic UI technologies, with stateful technologies. The changes are then transported to the backend, and the backend can execute the business logic, and of course, can also persist the data on the persistency on the database. So we get early feedback, and we also have the data loss prevention and other features as well. They come for free. So now let's have a look in the demo. I should give you a demo related to the draft handling and further features which we offer in the next releases, a lab review. So please let me explain you the draft from an end user perspective first. So we introduced the draft and said that we used draft to fill the gap between the stateless communication protocol and the stateful behavior of a transactional application. This helps us to get immediate feedback because the data is processed in the backend with each round trip between the data entries. And of course, this also helps us regarding the data loss prevention. So maybe let's first start with that one. So here in this Fiori application, for example, we see the different instances of the original active data. We can also see that here we can filter on the editing status. So I don't have any own drafts yet in the system.
But if I create now a new instance of the travel database, then I can, for example, enter an end date. I can also enter some kind of description, test for TechEd, and that we can see here that the draft is changed in the meantime. So if I close now this browser tab, we can see that in the second application instance, I can also again filter on my own drafts, and I do find the data which I just entered. So this proves that the data is stored independently of this browser instance, of this browser application instance, and that the data is persisted in the backend. Also the keys or the logs are already assigned to that if I go into an edit mode and not into the create mode. But maybe now let's proceed with this draft to see the immediate feedback for the changes which I do. First, I fill out the remaining values which need to be selected here. Happy Hopping is my agency, and I select Irene as a customer. Irene Waldmann. The starting date will be this 22nd of October, and the booking fee is like 200 euros. And now I can select also, or I can create some bookings as children of the travel. So maybe I select here again Irene as a customer. And for the flight number, I use the value help. And I select something from Deutsche Lufthansa, maybe something around August 28. And we can see that the remaining fields are already filled out correctly. So it's taken over from the value help. So if I go now back to the travel, we can see that the total price was calculated accordingly. So this was now immediate feedback depending on my booking fee and based on the bookings which I entered. So that was a draft from an end user perspective. But what about other features which we get for free if we are using RAP for transactional applications? So for example, if I filter again on all my instances, I can also, for example, make use of some generic operations or some specific operations defined for this transactional application. So for example, I can reject the travel if the status, the overall status of this travel is not yet rejected. And if I reject that one and go back, then we can see that this rejected instance cannot be rejected anymore, which doesn't make sense, of course, but we can accept the travel or we can also deduct the discount. So now let me deduct the discount, the booking fee, with 10%. I enter 10 and I deduct the discount. But basically nothing happened. We still have the booking fee of 306 euros. Let's try it again. I deduct this discount with 10%, but nothing happens. So why is happening that? So maybe let's open the developer tools. We can see now the backend connections. We can see that the batch was processed in the backend on the OData service DMO UI travel DD04. So now let's go into the backend and open this service implementation. In our backend development tool in ADT, I try now to open this service. So I enter DMO UI travel DD04. We can see here that this is a service binding. So at the beginning, the big picture of RAP, I told you that the service binding is the topmost layer. It defines the protocol and the use case which we want to use, which we want to support. And here we can see that this OData service is based on OData v4. We can also see this preview button here. So for example, if I select travel and click on the preview button, we can see that a new browser window is open. And the application which we just used to try out the draft functionality is basically not a real application, it's just the preview which I opened via the service binding. Since we know that this is now a backend, because we know that this is now an UI OData service, we can offer this preview functionality here. We can also see that the service definition is used. I introduce a service definition as a bracket around the scope, which will be exposed to OData. And therefore, all relevant CDS artifacts are listed here. So for example, the consumption view travel for draft. So let's navigate to this CDS view. In this CDS view, we can see that it's a projection. And I introduced the projection, which should be exposed by the service definition to create role-specific views on the real business object, or use projections also for CDS views to really select only the relevant parts. So if we now go to the behavior of this projection, we can see here in the Relation Explorer an overview of the business object, and that we have all the different actions being exposed here. So in the behavior definition projection, we select the relevant operations which should be exposed in this role-specific application. So it uses the action deduct discount. But if I now want to really check the implementation of this action, we go further down to the real business object, to the iTravel. The iTravel again is a root and selects data from a database table, or maybe in other scenarios from a CDS view. And here we also make use of the composition. So this is the data model of the real business object, where we have the first part, the data model part. And of course, we also have implementation parts. So now let's navigate to the implementation, to the behavior definition of this business object. We can see that it is managed. So it has a managed runtime. So we take over the CRUD implementation if you desire to have CRUD at all. It has draft functionality, and draft is nothing more than just this hint that we want to make use draft, and for the instance we also have to define the draft tables where to persist the draft. In the behavior definition of this travel node of the travel business object, we define the alias, which can be used in the ABAP implementation for a shorter name for convenience. The implementation is done in this certain class. I could also now navigate to this class to see the implementation for that. We see the persistent table because we have a managed BO. So the managed BO needs a persistent table to orchestrate the CRUD functionality, the transactional behavior. We can also see that create, update, and delete is desired for this business object. We also have an association booking with create behavior, which is supported via dynamic feature control. So for example, the booking should only be creatable if the travel is not yet rejected. We see that we have a UUID-based approach. That means the numbers are managed by this business object. We take over drawing the keys, the UUIDs. We can also see that the alternative key, the travel ID, is read-only the overall status and the total price. Why? Because the travel ID and the total price is calculated by the backend and not entered by the user, and the overall status is changed by the action. So it is also not possible to change the value directly. Other fields are mandatory, and for example, the booking fee is set to read-only once I think the travel is also rejected. And the other actions also have feature control. So we have the action accept, reject travel, which are toggled based on the value of the overall status. The deduct discount is only possible if the overall status is not set to accepted. So let's have a look in the implementation of the deduct discount, and maybe we find the error of this in the implementation. So I navigate forward to the method implementation via the F3 button. If I press F3 again, we come, like always, to the method declaration. So we can see here how the BDEV modeling is natively integrated into the ABAP implementation, because we now define a method, deduct discount, for modify, importing the keys for which the action is called, and also for which action we basically want to implement that. It's for the action of the travel node, which is called deduct discount. Now let's go back to the implementation of this action. We can see here that we loop over the keys which are provided and over the parameters which were entered by the end user. So if the discount percentage is not between 0 and 100, we obviously need some error handling. So we add then this key to the failed table, because if the percentage is not between 0 and 100, we are not able to proceed for this instance, and therefore we add this key to the failed travel instances. And of course, we also need some human readable error message saying that the discount is invalid, which is then added to the reported table. And we have a further look on the implementation. So first of all, the data is read, but not from the database, because as we discussed, the data is either in the original persistence for the active data or in the draft persistence for the draft data. So it doesn't make sense to try to select the data from the individual tables. That would be very inconvenient. And on the other hand, it's not always the case, like here in this round trip, that we do some changes on data which was not changed before in the same ABAP session. Because in more complex scenarios where one business object is calling a different one, it might also appear that first an update and then an action is called. So we need to make sure that we get the latest changes which are maybe currently stored in the transactional buffer, because before the complete ABAP session is then closed by writing the changes to the database in a more complex scenario. Therefore, we make use of the EML to read out the entities from the database or from the transactional buffer. We read the entries from travel. We are interested in the booking fee values, and we get back whether or not the read was successful or not. And if it was not successful, for example, the instance does not exist, for example, if it was called on an instance which was deleted in the meantime, or maybe the consumer of a web API provided wrong keys, then we also raise failed here. But if it was successful, we loop over the travel instances and we calculate the reduced fee based on the booking fee. And then later, after changing the booking fee, we can then modify the travel instances again by changing the booking fee value with the updated instances. And as we can see here, the full implementation is completely independent of draft, which is done by purpose, because we want to make it very easy to introduce a draft first of all, and secondly, it does not make sense to distinguish in the business logic between draft and non-draft instances, because the draft is just a technical aspect to cover the stateless scenario. But what is the issue which we saw? We did not see any change. This is of course because of line 129. We assign the original booking fee and not really the reduced one. We can change that. So we can do that. I activate the coding in the backend and I go back to my Fiori application. So, and if I try now again to discount, to provide a discount, we have 207 and I deduct the discount, 10% again. We can see that's now reduced to 186. So this is what we expected, of course. We can go have a deeper look on that again in the backend, because we are now in the implementation of this one. We saw the different behavior of the actions, for example. So let's have a look on how this feature control is implemented. We do have here a feature exit for all the changes, for all the flags which we have defined in the BDEV with feature instance for the actions or for the booking fee or also for the association booking. And this implementation is then provided in this implementation of the method getFeatures. Because if we move forward here, we can see that there are values provided for the requested features, which are then taken over from the BDEV: accept the travel, reject travel, deduct discount, the booking fee, and the booking association. And then, depending on the state of an instance, we can set the values accordingly to disabled or to enabled, or the booking fee to read only, or to unrestricted, depending on the travel status change, value. So having showed that, to summarize it, we have a full support of the draft, which can be easily added to a business object in REP. and we saw how this feels from an end-user perspective. We saw the different layers of RAP, the business object with CDS and BDEV, the projection on top, and then the service definition and the service binding. And we also learned a little bit about the dynamic feature control. So maybe let's go back to our slide deck.
So thank you for joining me in the demo. We will now have a look on the summary. So what are the features which we provided in the last releases and what's coming next? So first of all, our major achievements for the cloud and for the on-premise shipment are the following. So first of all, we offered now the managed business object with a huge feature set. So we offer now external numbering where the end user or the consumer of a service provides a key. And we also support UUID-based numbering like we did in the past with BOPF. Other numbering options are currently in work. So for example, using number ranges. Determinations and validations are there, and you can use them with different triggers like create, update, delete, but also field triggers. So field triggers are important because if you want to react on a change on a certain field, it's not really important if that was triggered during create or update. You just want to derive something. And also the breakouts, which I mentioned in the business object model, implementation types are supported already. We have the unmanaged log. If you don't want to use the generic implementation, but your own log object, we support the unmanaged save. If you have already your existing function module coming from the past, the additional save offers scenarios like supporting supporting change documents or application logging. So where you want to persist data additionally to the normal database persistency of the transactional data. The persistence mapping supports the use case that, for example, the CDS models is a little bit different than your database table, because the database table, at least for SAP, has 20 years old names, some strange German abbreviations, and of course in the CDS world, we want to have some nice naming conventions, human readable names. And therefore, the mapping in the CDS has unfortunately to be specified again in the BDEV, the behavior definition, so that the managed runtime can map a create or an update at the end of the day to the database persistence. And the draft handling is not only supported for managed BOs, like we saw it in the demo, but it's also supported for unmanaged BOs. So that means your unmanaged BO can be implemented via create, update, delete, and the save sequence log and all the operations which need to be implemented. And if you enable now the draft, you can also define determinations and validations, which are covered in the draft implementation then. They are, of course, not relevant for the unmanaged BO part, but only for the draft handling. So the draft is always managed. So we have two runtimes then. And common features are, for example, message mapping. So we want to offer an option that you can map your messages if we persist the changes of different business objects in parallel. So there's no other way to get the messages. And you maybe want to bring that into your context because your context is shown on the user interface. We saw already instance-based authorization and feature control. We also support operation check. So operation check, pre-check means that we execute a pre-check before the real operation is then triggered to say, well, it failed for these incoming values because they are not valid. And the BO viewer, we also saw the relation explorer showing all the different layers of a business object. Projection layer is, of course, also provided right now. And now the testability support was extended via the BO testable framework I mentioned earlier. The documentability, KTD documentation, is available for CDS, service binding, and for the behavior definition, the business object, with 2008 and the on-premise shipment 2020. So, but what are the next steps? So in the demo, we saw a lab preview, and some of the features are not yet available. So we didn't see, but it's also coming next, a global feature control and authorization. So not all authorization checks are depending on the real values of a document, but are more attached to the user. So for example, some users might not have edit operation granted at all. So therefore we can use global feature control and authorization to forbid that. OData before is just in progress. So we already saw the Fiori Elements preview as a lab preview, and the OData v4 support with the new Fiori Elements end-to-end programming model will be soon available. As soon as we also support the number ranges in managed business objects, then the create can be extended to draw the numbers here as well. The draft scope is really important if we have bigger transactions where multiple business objects, or to be more precise, multiple business object instances are included. So for example, for hierarchies, or where we want to update a business object into dependent object, or scenarios like that. And the draft scope is in the bracket around the transactional changes. Side effects are very important, and they are currently maintained in some annotation file in Fiori, and we want to bring that more to the backend because it's highly coupled to the business logic in the backend. Therefore, we want to also integrate the side effect modeling in the behavior definition. And of course, testability, documentability, troubleshooting like tracing, and extensibility is always what we want to move forward. So for example, extensibility is our current focus topic. So it must be there must be one way to extend applications for industries, by industries, partners, and customers, of course. So this is really important for us, and this will also show the big power of RAP if we have one modeled end-to-end programming model. So you will find further information on this wiki page or on this portal page, which is provided here. So for further information, we provide some links here. So for example, for all the features which are listed, we have already the documentation available if the feature is available. And you find here links for your convenience if you want to directly jump into the documentation of the individual feature. So, and of course, we also have public material where you can deep dive a little bit. So, and as usual, we would also ask you to continue your learning experience from SAP TechEd in 2020. So you have a lot of benefits and challenges you can do here. So please check out this one. And other than that, I would really say thank you for attending the session. And I really hope that you will use RAP in the future for your development. And I'm looking forward to present you in the future also other updates, for example, updates regarding supportability and extensibility. Thank you very much and see you soon.